So, hi everyone. Is this okay? Too loud? Okay. Um, I'm Wouter, and I'm from the Netherlands, and I have a company called Make, which tries to make continuous delivery easier to do for companies. Um, and today I want to talk about testing when you're doing continuous delivery. Um, This talk was triggered by actually another talk, one that a friend, a colleague of mine, Cirillo, gave at the Agile Testing Days last year. Um, and Cirillo was giving a nice overview of the role of the tester in the past 40 years or so in software, and how that had changed from um, the manual role in waterfall to the more participatory role in agile. And it was a great talk, but he ended that talk with a picture of a dodo, which at a testing conference you may imagine caused a little discussion. And worse, because he said, well, basically the classical role of the tester is dying out. And the reasons he gave for that were the experiences he had in one of my teams. So I figured I should have an answer for that. Because I don't think that that's particularly the case. And what I want to see if I can make clear in this talk is how much of a more important role testing is playing when you're doing continuous delivery. You just don't get one tester, you get a full team of them. And to do that, I'm going to go through and see what kind of types of testing we have and how that potentially changes when you're doing continuous delivery, and perhaps what new types of testing occur when you're doing that. So, wow, okay. So let's start with the core agile testing practice, test-driven development. Who here is doing TDD? No. That's actually pretty good. It's pretty much between 15 to 20% of people that do that. Even here, where I'm standing at the XP days, I've had it raise up to 25% when I was at a meetup that was particularly about TDD. And you might say that is an indication that there is a problem, right? If even the people that are supposed to be so much into XP are not all doing one of the core practices, something is going wrong. And in fact, that's also the reason why I'm so enthusiastic about continuous delivery. I have to admit that in this talk I'll just say continuous delivery. It's continuous delivery, continuous deployment. Continuous deployment is a little further along the road, right? Continuous delivery is being able to deliver at any point in time that you want to. And continuous deployment is delivering every time you push your code into source control. And the last one is a lot more fun, so I'll be referencing that repeatedly. Anyway, the nice thing about continuous delivery is that it finally allows me to actually do XP. If you are talking about testing, let's have another question. So, how many people know the phrase "I'm done. All I need to do is the unit testing"? It's usually something that people say during the stand-up, right? That thing goes away. When you're doing continuous delivery, continuous deployment, you have to keep your code base in a releasable state continuously. That's kind of the point. That's kind of it's there in the name, and that means that you cannot delay testing. So and it helps. Every time I've tried to introduce TDD in an agile team, you are fairly successful for a while, and then some dog of a manager comes by, and this is not working as I want. Yes, and before you know it, everyone is making a mess again. As soon as there's any pressure there, the good habits seem to fall away, and people get back into their standard state of working, which is understandable. When you're doing continuous delivery, that option is simply not there. If I push my code, it's in production 10 minutes later, and I didn't write the tests, then you need quite a sick mind to keep doing that. The system will go down, people will blame you, it will be very, very unpleasant. So in fact, you need to write your unit tests so very closely to the code that you might as well write a test first. And I've seen this happening every time that I introduce continuous delivery to a team that had loads of trouble working with CDD. And as soon as we start working as soon as we remove the safety nets, which I'll get back to later, people get into the mode of actually doing the test first. So it's when you're doing continuous delivery, at least you start getting the basics right. While I'm on the subject of unit tests, there is always quite a lot of discussion about what should we do, what level of test coverage is sufficient. I actually used to be fairly relaxed in that matter, but it turns out that if you turn that around, things become much easier. What level of test coverage is suitable? Just start with 100%, right? And keep it there. Yes, there are things that are unsuitable for unit testing. There's even areas of the code that you can't reach. So if you do find an area that you can't reach, and if you do find a place where you don't see a way to get the test coverage there, then you can stop, discuss with your team and saying, oh, this situation seems to be one that we can put a ignore test coverage marker on. And if the team agrees, you do that, coverage stays at 100%. Every time it drops beneath that, you have a reason to discuss. It makes it much easier to go about things. And again, yes, that's the other part of that discussion often. You can easily game things like test coverage, but if you are doing that, and so if you're writing basically a fake test, and your code is going into production, and the system fails, again, you have to be a very specific kind of a psychopath to keep doing that. That's not going to happen. So, then the next one. This is even better. Who's doing acceptance test driven? Oh, well, maybe you know it as specification by example, or BDD. I don't care. But who's doing this? There's almost the same people. That's cool. That is actually also not a bad score. Usually, the score for that is even lower than for straight TDD. This is another one of the core XP practices, the customer test, and again, this is one that is apparently hard to adopt. So, what changes if we do when we do this with continuous delivery? There's a couple of changes. If you look up the way that the old-time XP teams worked, what they did was they took a story, a fairly small story, and they'd write some acceptance test for that together with the customer. Then they take one of those tests and implement whatever was necessary. If any of you were at Giovanni's talk earlier, he talked about doing the walking skeleton. Basically, you do that for each feature, and you build on it step by step by implementing new acceptance tests, new acceptance scenarios. And again, it's a practice that has been hard to get adopted. If you're doing continuous delivery, especially if you're doing continuous deployment, you very quickly get used to having to push new code into your source control with something that works. It has to be tested, so you have to have a test for that. It has to be also be unit tested, and if you do that and if you push that into production, you usually hide that behind a feature toggle or something like that. But you start working much more incrementally on that basis. And what's happening usually with the tester role in the team then is that during the preparation, let's see, we work with the three amigos. Does anyone know the three amigos? Yeah, there's a couple. So the three amigos is a term that I think George Dinwiddie came up with that demonstrates that if you are discussing your requirements, your user stories, that you need at least someone from the business, a product owner, but preferably someone from the business. You need a developer, and you need a tester. In practice, there can be more roles involved, but at least you need that core to discuss what your features are going to be, what kind of impact they're going to have on the system, and as a result of that, you will write your acceptance scenarios, your acceptance tests. Now, most of the companies I come into, it turns out that their previous agile coach was Donald Trump. And he convinced the whole company to build huge walls between each of the three amigos, and oddly enough, he even managed to get everyone to pay for it as well. This was much funnier a month ago, but anyway. So there's usually a lot missing in this process, and we tend to see that. The requirements are minimally brought to the team by the product owner, and tester isn't involved. Developers usually are involved fairly lately, so you have a lot to work there. Again, when we're doing continuous delivery, you have to have things ready because you're releasing at a very high pace. You have to have these scenarios available because you're not waiting for the story to be finished to release it, or at least to push it into your source control, where it can potentially be released, even if it's not available to the end user. And doing that, you get automatically a nicely more iterative process, where testing is also more iterative and done on a day-to-day basis. Now, another thing is, and then we're going to get to more technical tests, the testing pyramid. I always want to call it the testing triangle because there's no depth in this. But anyway, the testing pyramid. Who knows the testing pyramid? Yeah, everyone knows the testing pyramid. That's right. So, funnily enough, I was in the XP conference in Edinburgh in May, and they had a panel session about the testing pyramid, and pretty much everyone that is anyone in agile testing was there. There was like Uncle Bob was there, Bob Martin. We had Elizabeth Henriksen was there, Simon Brown, Matt Wynn from the BDD side, Steve Freeman from the Goose Book. So there was like a who's who of testing, And so the question was, is this thing, was it a good idea? And turns out that no one actually agreed on what the use exactly of the testing pyramid was. Except for one thing, is that it was a good idea at the time. It was basically a way to convince people to stop writing only end-to-end tests and almost no unit tests, and to flip that around. So that was the goal of the testing pyramid. It kind of succeeded in that, so that's good. But in reality, it's not really a pyramid, right? There's more to it than that. And I actually suggested that we should make it a testing fractal, but that was even harder to explain, so that's not going to happen. So let's have a look at what kind of tests you will encounter. Because if you're writing your unit tests, and again, we are at 100%, right? Then you're already doing pretty well. But if you're writing a grown-up system with usually multiple components in there, then you need more than that. Let's see. We have a very basic system. We have two services. There's an external API component so that we can give something to the outside world without hard coupling that to all of our internal services. Our services have their own databases, like they should. Well, one of them actually uses an external API. And if you build those kind of things, then you'll build them from certain building blocks that always occur in those systems. There's a little data access, there's your domain part of it. There's the services layer that connects that all together, and then there's something that implements the protocol to the outside world. So something like that. Oh yeah, and they talk to each other, otherwise there won't be much use to this. So when you start with unit testing, that's great. And that will usually be focused in these areas. You'll usually focus most of the unit testing on the domain and in the service layer. There will be unit tests elsewhere, but hopefully the amount of business logic elsewhere is minimal, right? So you'll have some unit tests, but they're basically going to be just testing whether the glue code that you have there is actually working. Now, that's great. And that's actually going to be, if you're doing this and if you're doing this well, you're already ahead of the curve looking at what most teams are doing. But then we have integration tests. And that's another maybe a semantic discussion, but an integration test is not an end-to-end functional test. Just to be very clear about the terminology, because everyone uses something different. I have an opinion, so here it is. An integration test tests whether two components can actually talk to each other, right? Very often an integration test will be useful to have in a running system, just to see whether my service can talk to my database, whether the schema version is the right one, so whether I can actually read something from the database, and what exactly happens if I can't, or if the database gives me an answer I don't expect, or if one of my other services, for instance, has a performance issue and the time it takes to get an answer decreases, or I don't get any answer from that. That's the type of thing that an integration test tests. The integration test tests integration. I got it. Okay. So very closely related to that, there's the contract test. A contract test doesn't test any functionality. A contract test tests whether the language that the components are speaking and the language that they're speaking to each other with are right. that also means that the contract test will very specifically test, in this case, is the place where you implemented the API, right? Where you implemented the networking code, or the client of that. That's all it tests. So if you are adding a field, then the contract test will test whether you actually deserialize that field, for instance, or what happens if my version 101 client gets a new field added. Version 101 client talks to a version 102 server. Does it fail when I add a field at the server and the client isn't there yet? Do I manage those kind of things correctly? That's what a contract test does. So, having that, there's another very important piece of testing, and that is actually mostly functional, and that's the component test. And you can have component tests that's different levels. Which one did I start with? The internal one. So, and that's important. This is also often the level that you hook in your behavioral type tests. These are actual functional tests. These are usually the type of tests that you've discussed with your product owner. Most of those will not be end-to-end test. I'm not using the terminology of the acceptance scenario or the acceptance test because that's not important for this discussion. But usually, if you have those, they hook in at this level. It also means that they usually, for a large part, can hook in at a level where they do not need the component to be running in a production-like state. Very often you can run these type of tests in exactly the same way as you would run your unit test. They're different tests though, and they have a different purpose. So they are a different category. And some of them you will definitely, I didn't do this right, okay. Some of the component tests, you will definitely run from the outside. So they will go through the REST API. But that should be a fairly low percentage, and only the ones that require that. Usually those are the ones that require something of a separate component to be there. And the last category is the end-to-end test. And usually, again, there will be a few of those. In most of the systems that I've worked on, you can literally count that on two hands. So most systems have a couple of high-level flows that are there for the system, right? That 90% of the customers go through, and those flows are the ones that you will do an end-to-end test for. It will not test for variations on that flow. It will not test different scenarios. It will not trigger different functional areas. You'll have these tests simply to see whether everything is connecting together. So where the integration test tests integration in the small, the end-to-end test actually tests functional integration in the large. Now, and this, unfortunately, is still a simplification. And I'm emphasizing this because what I've seen is that many teams, when they start to take testing seriously, they first go for the simplistic method and take something like the testing pyramid, assume that that's it. So they take those three categories of tests and start working on them. And usually it becomes more of a square because much of the effort is still on the end-to-end test. If you do that, then it's pretty much guaranteed that you will not be able to keep up. Depending on the speed of development, usually within roughly half a year, you will get too many end-to-end tests, things will go too slowly, you'll be spending more time finding out why tests were failing than actually developing new functionality. You will slow down considerably. So make sure that each test that you write, that you know what the purpose is, and that you only test the thing that you want to test. Or in other words, don't repeat yourself, because that's the alternative. Let's see. Yeah, one other doesn't really belong here, but I can't resist, because that's another part where people get in trouble when they are moving quickly. If they have any type of dependency on an external component, then very often there's still a direct link to that component, and I've seen delivery pipelines break down simply because the payment provider that did give us an acceptance environment is unreachable, and suddenly for a full day our delivery pipeline is down. That is unacceptable, and there are good ways of dealing with that by simply making sure you have your own service in between. It also gives you decoupling from whatever's out there. It allows you to change service providers, if they're down too often. And it allows you to both test your own functionality and create a test in the direction of the external service, so that you know that the functionality that you're using is actually still operational. That last test then will not be in your delivery pipeline. It will be somewhere else. It will probably live more as a monitoring feature. But we'll get back to that. Most important thing is use all the tools that you have available and test for the right test in the right way for the right purpose. Now, much of this, everything that I've talked about so far is about automated testing. We are not trying to get rid of manual testing here. That was one of the most vehement discussions points in at the Agile conference. But what we are trying to do is make sure that our testers can actually use their time to break the system. This is a skill, and this is definitely one that I've seen that a skilled tester can do things that most developers would never dream of, even in their worst nightmares. But most of the discussion came from this addition, because in the teams that I've worked with, we've actually gone and done continuous deployment, and I've told my testers, yes, you need to spend that time on exploratory testing, and it's very welcome, but you're going to do it in production. We are not going to wait for you. To do that, of course, you need to be at a certain level with your test coverage. If you don't do these things right, then you're never going to feel comfortable removing that final manual test. Which is also why I usually give a little break for the... Are there any testers here? 1, 2, 3, 4, 5. Cool. So this is where you can shoot. Every time, this is a huge discussion, and oddly enough, though testers are usually uncomfortable starting this, it's the developers that are much more hesitant to do this. And that's, in my opinion, because a tester is used to being the safety net, the final guardian of the quality of the system. And that's all great, and they feel that responsibility. That's wonderful. But the developer is actually used to having that safety net. And when you start removing that becomes very uncomfortable for a bit. On the other hand, too early. On the other hand, when you remove the safety net, suddenly the dynamics in the team change drastically. So um, I've been to a bunch of testing conferences now, and I've tried to get into contact with the testing community. One of the things that is something that you hear very often there is that they don't think that developers have the quality mindset. The developers are not thinking about the system in production. They're not thinking about all the things that can go wrong, and that's not quite right. Developers definitely want to do things right, but they don't have all the tools to do that. They don't have all the training to do that. As soon as you remove that final safety net, as soon as you make sure that there's no longer a button, but the system will deploy automatically, the whole dynamic in the team changes, and the discussion changes as well. It goes from I was talking about the discussion about test coverage. The discussion goes from should we write a unit test for this to yeah, we have the test coverage at 100% and this is tested, but I'm not comfortable releasing this because I think we're still missing a type of test here, because this area, it's unit tested, but I'm not sure that it's going to work with that. So maybe we should, oh yeah, that contract test you were talking about, maybe can we include that here? It becomes a much more active search for quality in the whole team, because everyone at that point is able to break the system, is able to break the build. And that is a very interesting change that you get. I was misdirecting you a little. The testers are not the only ones that are the quality safeguard, because there's someone else, which is the operations engineer. Yeah, there's been a couple of talks about DevOps. There's a reason why continuous delivery and DevOps have risen at the same time. I think they were both on call, and so the operations engineer is always worrying about the state of the system and about the quality. And oddly enough, a large part of what he's doing is writing monitoring checks to see whether the system is still running, which, if you look at it in a certain daylight, is actually a test. And interesting things happen if you combine the functional and business view of a functional tester with an operations person in the team and make them write those kind of checks together. I've seen the amount of priority one calls, the things that actually wake people up, go down drastically, and the duration of issues go down drastically, because a bunch of more business-aimed tests were added to the monitoring system, and our operations guys can suddenly easily judge whether something is important, or just an issue, and we'll fix it tomorrow, simply by getting a more extensive view of the system. There's a wonderful article by Liz Coe talking about this in terms of discrete versus continuous capabilities, which I really recommend people read and get a feel for that. That was that one. But all these types of activities are already there. They're just being seen in a new light. But there are new things. With continuous delivery, pretty much automatically comes infrastructure as code, and that means that we have infrastructure as code. And if we have code, I think we should have tests. Now, for infrastructure, we do have some tests, as I said, in the monitoring sense. but that has a very slow feedback cycle and is not very useful when you're developing this kind of code. I don't know, anyone here used like things like Puppet or Ansible and that kind of stuff? Yeah. So developing that is sometimes a little frustrating because it's very hard to find out if what you did actually worked. Now, for Puppet and Chef, there are some unit testing frameworks already. I know that at my company we're using Lint and Service Pack to test our Docker images and also to test the deployed Kubernetes environments. So new tools are becoming available for testing infrastructure, which is good because in my experience, the old way was very, very frustrating. So so there's a lot happening there, and it's still in very rapid development. So you have to take into account that the tools are still flaky, still missing large chunks, but they're also already delivering a lot of value. So if you do this kind of development, you should have a look at that. And the last one, which I'll do very shortly, but the last one is actually the business test, which I've talked about in more detail in my talk yesterday. The same type of testing mentality can be used in the area of business, in the area of requirements, and starting work on something by first defining what you expect the business result to be of it is a very powerful tool. It is usually called nowadays hypothesis-driven development, and it basically means that instead of your usual user story, you actually define ways where you can measure what the impact of your new feature will be, so that you at least know whether you were successful or not at a higher level. And again, getting back to the fractal, at each and every level, testing becomes more of an issue. Yeah. So the result of that, I think, means that you can go faster in your business. This is mostly based on stuff like Eric Ries's lean startup ideas. What is very important to know is that this is like the final step. It doesn't make that much sense to do this if you can't deliver quickly, because you won't be able to react on the results of your tests. So it all builds on each other. And I think that's it for me. So does anyone have any questions?